Hi, this is Mr. Peter Hansel. I'm going to walk you through how to do 14 triangle. A lot of you expressed to me that you had some trouble with 14, so I'll do a couple for you and show you. If you're still sitting with this homework and you still have it in your binder and haven't handed it in yet, show you how to complete it. What we need to do is we need to fill in these circles with the possible compounds that can form from the mixture of the compound that's directly above it and the compound that's directly to the side of it. So for example, this circle here, I'm going to need to be looking at the compound above and the compound over to the side. I'm gonna do the 3 steps that I taught you in class. Step 1, you need to figure out what the ions are. And to do step 1, you need this, your ion table, the front and the back. I think you should go ahead and for all the compounds, just fill in the ions before you even start filling in the circles. So for example, Ag, I'm gonna find the version of Ag that's on my half sheet. I see it right here, Ag+. I'll write that right above Ag+. NO3, look for that one, scan through my sheet. You know, by now, once you work with the sheet, you should start to become comfortable knowing where the different chemicals are. Ba is on the front, right here. I'm gonna put Ba2+, Cl right there. You're gonna do it for all the different compounds that you mixed, and when you're done, it'll look like this. You'll have your ions drawn out, and then it's just a matter of swapping the partners and then doing the crisscross method. When I say swap the partners, I mean at first, if we're looking to fill in this circle here, at first the partners are Ag is with NO3 and Na is with CO3, but the partners are going to switch. So Ag is going to be with CO2 now, or sorry, CO3 now. NO3 is going to be with Na now. Okay? So let's draw our new pair, Ag+, CO3 2-, Na+, NO3-. But we're not done. We need to do the crisscross method, okay? That's why I'm using a pencil with an eraser, because I'm actually going to erase the number that has the charge, the 2-, and write it next to the neighboring atom. This 1+, I'm gonna erase that. I'm gonna write a 1 now next to CO3. With the polyatomic ions, you gotta put them in parentheses, so you know that it's all together. It's all one unit. Okay, this 1 I'm gonna put next to NO3. This 1 I'm gonna put next to Na. You don't have to write the 1s. You can take the 1s out. There's 2 2s, you can also take those out. And you have our 2 compounds, AgCO3, NaNO3. The final step is to see if they're solid or liquid. And to do that, we use the rules, the solubility rules. You're going to scan through the rules to find something that has to do with your compound and see what it says. AgCO3, when I scan down these rules, the first time I see Ag or CO3 in them is on rule number 5. It says phosphates, carbonates, sulfides, and sulfites are insoluble, except when combined with a group 1 metal, which Ag is not, or NH4. So it's insoluble. Remember, insoluble is from the class notes, means that it's going to be solid in water, and soluble means it's going, soluble means it's going to be aqueous in water. Okay, so what we found out is AgCO3 is solid in water. NaNO3, look through my rules, I see rule number 1, Na, blah, 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 is soluble. So it's aqueous. Okay, so I know that my PPT, now you'll have some observations written in these circles already. That's the difference between your sheet and my sheet. And if you observed a PPT, I said to circle the PPT, so we're gonna circle the solid. PPT and solid mean the same thing in this case. Okay, let's put it all together and do another one. And this circle here, the F2 circle. The F2 circle is the combination of the K3PO4 compound and the BaCl2 compound. I'm going to swap the partners. Okay, so look, you've got BA is paired with Cl, K is paired with PO4. K is now going to be paired with Cl, BA is now going to be paired with PO4. So I'll show that, K plus, Cl minus, BA2 plus, PO4, 3 minus. I need to do the crisscross method here. So what I'm going to do is I'm actually going to erase the charges and write that number next to the neighboring atom. So I'm going to erase the plus that's next to K and write a 1 next to Cl. I'm going to erase the 1 that's next to the 1 minus that's next to Cl and write a 1 next to K. Now remember, when you write the 1, you might as well not write the 1 because you don't need to write. Writing nothing means 1. BaPO4, I'm going to put this 3 down next to BA. I'm going to put this 2 down next to PO4. The final step is to decide if either of these are a solid, because that means that they're a PPT. I use my solubility rules, figure that out. I'm looking for K or Cl in my rules. I see that K is in rule number 1 and it says it's always soluble. Soluble, remember, means aqueous. So I'm going to put an AQ sign next to KCl. And this should be written really, they're together. K and Cl are together. BaPO4, I'm looking for Ba or a PO4 on here. I find it on rule number 5. It says PO4 is insoluble. It gives some exceptions, but those don't apply to barium, to Ba. So I'm going to go ahead and write an S, solid, because it's insoluble. And I'm going to go ahead and circle it because solid means that it's a PPT, or a precipitate. So